Hi and welcome back. Tonight we've got another debunk attempt on the MAGE experiment. Before we get stuck into it, I'd like to say thanks to my members and patrons. I want to give massive thanks to all of my supporting members and patrons. Thank you all so very much. So tonight we got Brian's logic. Let's see how he does. Okay Brian, over to you. Roll VT. Right, this is Brian's logic and his attempt at debunking MAGE. Go ahead, Brian.
Hey, how you doing?
Not so
I
bad.
wasn't going to address this, but it seems as other people have done it, like Flatside and that.
They didn't really though, Brian. They waved their hands about, cherry picked, didn't understand, ran away and called it a good one. I hope that you can do a bit better.
And Mr. Sensible is still holding tight. I'm going to address the MAGE issue.
Holding tight to the fact it's a globe Earth. Yeah, I am, mate.
Okay, one of his main complaints about Flatside's video was that Flatside was looking at his wide-angle lens video.
Yeah, that was quite a complaint. He was looking at the wrong video with the wrong camera. I had the whole point of MAGE was to send up a narrow angle camera with reference lines in front, which is what I did. And I did a video about it, which was an experimental video. I also did a full launch to landing video using that same experimental narrow angle camera so that no one could accuse me of cheating. Instead, he decided to debunk the third video, which is a wide angle camera with severe distortion, which is labelled as wide angle camera or wide cam on the video. It's entitled wide camera. I think in the description I said it's a wide camera, and in the introduction I also said it's a wide angle camera with distortion, and it's not to be used to try and debunk the Earth because it's the wrong one, and I gave a link to the proper one. So the fact that despite all of that he still debunked that one, yeah, I had a bit of a problem with that.
And not his narrow angle lens video.
Exactly.
And Flatside was pointing out that it's lens distortion.
Well, no bloody surprise. It was a wide angle lens.
What I would say to Mr. Sensible is that if you have a problem with people viewing your video as the wide angle lens version, then why are you showing it in wide angle lens? Why is your video not only narrow angle lens?
Well, I would like to tackle that, Brian, with this.
So this is showing convection here. So this person has 3 mugs and the one in the middle has hot water in it.
Brian, why are you doing a video about convection currents when you're trying to debunk MAGE? Oh, it's just another video on your channel. I mean, I only put up the wide angle camera version because it gives people a nice view. And I'm sure that you only have got a video on your channel about convection currents because on that video you're talking about convection currents. It's nothing to do with your debunk of MAGE. It's just another video. I knew that I knew that flat earthers would either get confused or cherry picked. So I made it very, very clear that that would be the wrong video. But still, yes, Flatside managed to do it. So leave that aside. The fact he managed to get the wrong video was one of 2 things. Total bloody incompetence or dishonesty. He can take his own pick on that one.
And the video in narrow angle lens, where is it? Yeah. I just show it, go back a bit on it. Yeah.
I will pause it just for a second. That is the correct camera, but as you can see it's MAGE full uncut 127,000 feet. So that's not the experimental one. You can use imagery from there, that is fine, but it's not the actual experiment where I make my claims and present my evidence. That would be nice for someone to actually tackle that.
I'm going to show something. It just seems to go up and down, up and down. Let's see, is that where are we?
Well, we couldn't make a rigid tower that tall. Of course it goes up and down. It's a 25 metre long approximate string between a great balloon of gas and a 1 kilogram weight swinging around. Of course it's going to swing. I don't see what your problem is with that.
We're not seeing what we're supposed to be seeing if we were on a globe.
You're seeing exactly what you're supposed to be seeing if you're on a globe. You can see it there on the screen. Curvature. What do you expect? I know what you expect. You expect that if it's a globe, you're going to see sort of a curve like that. No. This is a huge flipping sphere, and we are comparatively very close to the surface. However, we are far enough away that you can see a slight curve.
The curvature is not there. I mean, even if it's narrow angle at that height, you'd be seeing you would be seeing ridiculous distances.
Well, when it's at full height, I think you can see about 700 kilometres. I don't see why that's ridiculous.
If you want people to see your video as it is in a narrow angle lens, then don't put out a wide angle lens version.
That's ridiculous, Brian. It's a totally separate video and it's fully labelled up. If someone can't read the simplest of instructions or listen to them as per the beginning of the video, then they really are total idiots. Obviously you're not, because you're looking at a video with the correct camera. So that's a good start. I want to see what you do with that.
Just put out a narrow angle lens version. You can show them the wide angle lens in one of the smaller windows up at the top of the screen.
Actually, I did. Oh, carry on.
So that you can't use that as a complaint.
Yes, I can. I will, and I did. The guy is a chuff nugget.
Against Flatside, because that's not a complaint. It's your video. You put it out there. Now, your narrow angle lens doesn't show any curvature.
Yes, it does.
And I'm going to show this in a minute.
Good.
I already just showed it anyway. But this is the Stratosphere, right?
Yep.
Now, the height that MAGE 2 went was 37,000 meters. Okay?
Good. Correct.
So 37,000 meters. So this is the Stratosphere from 10 kilometers up to 50 kilometers. So you can see here this weather balloon here, or this balloon here. They're showing that this is the height. This is like, so MAGE went to about here, MAGE 2 or whatever.
Yep, that's just a rough diagram, and I agree absolutely.
Went to about this height, 37. You can see with the balloon, they're showing that balloons, that's kind of the height balloons go with it, right? They don't get past that point because of the low pressure. Now, the pressure was about 2 torr.
Yes, it was, but
right, around 2 torr, because he was getting, Mr. Sensible was getting from 260 Pascal, I think it was, to 310 Pascal.
Absolutely right. So I don't know why you're hovering your mouse over the 10 to the power of 2 torr. You don't know what that is, do you?
I'm just going to go see what was the 310 Pascals here, but he also shows in another video 260. So
yep.
260 Pascals, if I remember correctly, was 1.9 torr.
About that.
So we'll say around 2 torr.
That's not 2 torr that you're highlighting. That's 10 to the 2.
So this is a vacuum chart in torr. So here you can see it's at the very low vacuum.
Right. That is 10 to the 3. That's torr in the hundreds. 760, that's sea level. We live in a low pressure, low vacuum system. MAGE got to 2 torr. That's here in the units. It was a medium level vacuum. I do want to give you credit for realising and understanding that it was 2 torr, that the pressure had dropped. So honestly, well done for that, Brian. But you don't know where we are on the scale. 10 to the 2 is not 2 tour.
Area, right? About 2 torr. So his pressure was in line with what we would expect. What we would expect, what the mainstream say, that's what it should be. Grand.
Yes, it was.
Now, the thing is, just go back to, sorry, let me use this again. They're showing a balloon here because balloons don't really go any higher than about 40 kilometers. That's as high as they can go. So the problem is that after this point in the stratosphere, and I know this because I've checked, when you start going anywhere past this, everything is a calculation.
Nope. I appreciate you said you checked, but you obviously didn't come across sounding rockets, where they send up rockets up into the mesosphere to take actual measurements. It is not all just calculations. But that's above MAGE, and that isn't anything MAGE looked at anyway. MAGE was looking at the Earth. The fact that we had other instruments on there was just a bonus. The main thing is the camera. So although it's very interesting what the temperature and pressure and whatever it is would be in the stratosphere above MAGE and the mesosphere and so on, that's not what I looked at.
There's no measurements past this. If you look into how they measure the temperature and things in the mesosphere,
sounding rockets,
they'll try and say they're using thermometers and barometers and different things, but they can't up there. If you look into what it really is or what it's really supposed to be, and their claims about it, they can't.
There's even a picture of a rocket there. That's not a rocket in space, because look, that's where meteors are burning up. A rocket, for satellites, has to be higher than that.
Can't be doing what they're saying they're doing, because it's impossible. So, but I'm not going to argue about that now.
Well, I've done 6 impossible things before breakfast. I'm going to round it off with breakfast at Milliways, the restaurant at the end of the universe.
I'm going to stick with the stratosphere. So this is the height the stratosphere is at.
Yep.
Where the balloon is.
Yep.
So MAGE is about that height.
Yep.
Right. So it's going to go here. So stratosphere. Here they're talking about the stratosphere.
Now, Brian reads a lot of stuff out. I'll just skip past it. I'm not denying anything that's said on that screen, okay?
Okay, as a result, there is little mixing of air within the layer, is what they say, right?
Right.
So it gets warmer as you rise.
Right.
That's what they're saying. Sorry, my that. So we're just going to move on here to this, right? So see, this is, they're saying here that at the boundary between the mesosphere and the stratosphere, this is which is the stratopause, is about 1 millibar, right, of pressure, which is about in line with what Mr. Sensible was getting. Yeah, his pressure is about right. The problem is, as I said, after that, they can't do what they're saying.
There is another problem though, Brian. How is the pressure only 2 torr at that height? Because we get no end of flat earthers saying gas pressure requires a container. Well, the pressure down at sea level is a lot greater than the atmospheric pressure at the top of Everest, than the atmospheric pressure that aircraft fly at, than the atmospheric pressure where MAGE was at. So they had different atmospheric pressures with no container between them. Flat earthers have got to explain that.
After this, they can only get balloons up to about that height, and after that point,
they use other means.
If you try and find original sources for the supposed measurements of stuff in the supposed mesosphere, you'll end up at calculations.
Well, I'm not going to go into it now, but if you want to, or if anyone wants to find out about it, look up sounding rockets. So move on, Brian. It's not applicable. Because
what they're claiming can't be done, considering what they're claiming. Right? Well, we just move on. This will all become more clear soon. Right?
Good.
Stratosphere, atmospheric layer, where temperature rises with altitude. Right? So once again, they're saying it goes up to a height of 50 kilometers. MAGE went up to 37, right?
37.
So once again, there's it's to do with the ozone layer and different things, right? That's another argument, right? Move on again, right? This region, this is the stratosphere here. This region of increasing temperatures is the stratosphere, spanning a pressure range from 100 millibars at its base to about 10 millibars at the stratopores, top of the layer. So they're saying it should be 10 millibars. So I'm not going to argue about the pressure issue. I'm not too bothered about that.
Good. Which is more than can be said for other flat earthers. So we agree. MAGE has shown a pressure gradient which it graphed, and you don't disagree. Cool.
It's just at a 2 torr up at that height, which I don't really argue with. It's like, I mean, that's the way it is. There's that pressure gradient. I know what causes that, and it's not gravity.
Oh, if it's not gravity, you better come up with an explanation.
But we'll move on.
Oh, great. Brian, gravity is the perfect explanation for it. You've just hand-waved it away and said we'll move on. You've made a claim, you need to substantiate it. Let's move on.
Now, the stratosphere, this is where things get tricky, right? There's 3 problems with the Mr. Sensible.
Right. Sorry, interrupt Mr. Sensible's MAGE. 3 problems. Okay, Brian. So, forgetting everything we've said so far, we're starting now. You found 3 problems with MAGE. Let's see if we can bat those away.
The stratosphere extends around 31 miles, 50 kilometers. The other diameter from 4 to 12 miles, about 26 to 20 kilometers above the Earth's surface. This level is 19% of the atmosphere's gases, but very little water vapor. So very little water vapor. Right, in this region, temperature increases with height. Heat is produced in the process of the formation of ozone. This heat is responsible for temperature increases from an average of minus 51 degrees at tropopause to a maximum of about minus 15 degrees at the top of Celsius at the top of the stratosphere. Right. So they're saying here the lowest it can go is minus 15 degrees at the top of the stratosphere, right? This is what they say, right? That's 50 kilometers up, right? Now here they're saying...
Brian reads out this entire section about the stratosphere, none of which I disagree with, so we'll just skip on.
50 kilometers once again, and they're saying here that it's about 1 millibar. That this is about, so the average height of the stratopause is about 50 kilometers and it's about 1 millibar pressure, right? Which would be in line enough, close enough to what Mr. Sensible got.
Cool.
Right, blah blah blah. So now I'll go back. Where are we? Was it this one? To this one. See, was it here? Oh, sorry, now I'm after losing. I have so many things open after losing that, which I'm looking.
That's the problem with multi-tab IQ research.
Another temperature thing where it said that, don't really matter, I can just say it. It said that the lowest that the temperatures get is 0. I can't find it. I'm after losing it.
Don't worry. I'm sure you're right. I've had a look and it appears you're right. The highest temperature that you're going to get near the top of the stratosphere is 0. However, Brian, the one thing that you do not seem to have mentioned at all is that there is a large difference between the temperature profile for the summer than from the winter. However, I'm not going to use that.
I was talking about the lowest the temperatures get is 0.
Highest.
At the top of the stratosphere.
So I know this is a hard concept, but minus 15 or whatever is lower than 0. 0 is the highest temperature. That is your point.
So I'll just go back to here, right? So they're saying here, this is the important part. There's minus 51 degrees, right? And it goes to at the top of the stratosphere, which is 50 kilometers up, minus 15 degrees, right? Now I've also read that, I just can't find it there. I also read, and I'm not going to hide this, that it gets to 0.
That's fine, Brian. I'm not going to accuse you of hiding that. So basically, we got the stratosphere going from, it says an average of minus 51 up to minus 15, maybe up to 0. That's cool. Carry on. I'm not going to deny it.
Degrees, right at the very top. It can get to 0 degrees.
Yep.
This is what they say. Now this is where the problems get very tricky.
Aha.
This is why Mr. Sensible has plus 4.8 degrees Celsius
I have indeed.
at 37 kilometers up. He really should have, if going by what they say here, and this is from weather.gov, right? This is what they say. This is weather.gov. This is who this is, right? They're saying a tropopause to a maximum of about minus 15 degrees Celsius. So I'm going to read this again, right? In this region...
No, you don't need to read it again. Don't labour the point. Yes, the figures on that website say up to minus 15, and you said you've seen somewhere else up to 0. I'm not denying that. I'm also not denying that MAGE got a reading of 4.8. There's two things, or a couple of things you need to remember. One, MAGE wasn't up there to take temperature measurements. MAGE had a simple and cheap dual-purpose sensor. It was the air pressure that we were after, and as a bonus it gave temperature. So he reported it. What is interesting is if you monitor the temperature gradient, you can see the temperature drop as it's going up through the troposphere, rise as it goes through the stratosphere, and then of course reverse when MAGE burst and started to come back down. The temperature, I'm happy to concede, was not very accurate. But it's not just the sensor's problem. We're aware of that as a problem because in the original video we put a cover over the temperature sensor in order to try and shield it from the sun, which would warm it. Now that MAGE probe was swinging around. There's nothing to stop the sun at times getting under that shade and shining on the sensor, overheating it. You think if you want accurate weather readings, you don't just stick a thermometer out in the middle of your lawn. You have to encase it in one of those weather stations. Direct sunlight and other factors will affect the temperature. Now, we just stuck a nifty little shade over it to help. But, you know, I'm happy to fully accept it was not accurate because that's not what we were going up there for. And what's more, Brian, I hate to break it to you, but even if that temperature is 5 or 10 degrees out, that doesn't change the shape of the Earth.
So, right, what they're saying here, and this is weather.gov, jet streams, layers. So this is who this is, right? National Weather Service.
Yeah, Brian, you don't need to keep repeating it. You've made it clear. That's the temperature range. I'm not disagreeing. I'm saying that a combination of that sensor perhaps not being scientifically highly accurate in combination with and or not being shielded properly could be a misreading. That's fine. I'm happy to concede that temperature reading was wrong. So your point one of the 3 problems is not exactly a killer for the globe.
But he has it at like MAGE, well, not him, but his data, Mr. Sensible's data is at plus 4.8. So straight away, that is not in line with what the mainstream say.
Well, as I said, it does show the gradient in a chart like this, and that does mimic the mainstream. And with regard to the pressure, I was able to do a sanity check on it. All of this is in the original video. In the original experimental video, you can see, and I briefly explain about the shade over the sensor, and also with regard to the pressure, which is a lot more important, I did a sanity check. I checked the reading at the same height as the top of Everest, and it was pretty accurate. And that's the one that's more important.
So MAGE is actually in violation of the mainstream claim, or the mainstream claim is not correct. So technically MAGE so far is not in line with the globe model.
Well, that's not the globe model. That would be atmospheric modelling models, because that's nothing to do with the shape of the globe. And yeah, MAGE is reading that 4.8 just up there above my head, whichever side it is does not match the highly scientific and specialised and no doubt very expensive readings that are taken with sounding rockets and the like, where they actually are going out there to do those exact measurements. That's not what MAGE was for. Right, so that was problem 1 of 3. And as I said, yeah, I got a different reading, but it doesn't matter. Now on problem 2.
There was no rotation to be
Oh, for goodness sake. Well, I'll let you speak about it briefly.
seen. This supposed rotation, there was none of it to be seen in the video. Now, Mr. Sensible said in his reply to Flatside that was because that we have the conservation of momentum going on.
Absolutely. The Earth is rotating at a certain speed at the location we were at. The atmosphere was rotating at the same speed. MAGE was floating in that atmosphere, and so is carried along at that same speed. You would not see Earth rotating. I was thinking about this. You drive your car along at 50 miles an hour, okay? Your car seat, you would say, is going along at 50 miles an hour as well, isn't it? But if you're sat there and look down at the seat, is it moving past you at 50 miles an hour? Of course not. It's in the same reference frame. It's in that car with you and your ass sat on it. Why would you expect the seat to move at 50 miles an hour visibly? You wouldn't. So why would you expect that balloon to move at X number of miles an hour? We don't. It's going the same speed as the atmosphere along with the rotation of the Earth. So your point number 2 is just wrong. We are not claiming that it should. If you are claiming that it should move at a different speed than the Earth if the Earth was rotating, you need to come up with an actual explanation. It's your claim, not mine.
Right, more or less, where all the atmosphere moves with the supposed rotating globe out.
Yep.
But he's at 2 Tor. So at what point does things not move with the atmosphere in the globe model?
Well, that is part of the atmosphere. It's got momentum. If you've got an air molecule almost that height but still going up, it's still got its rotational momentum. It's going to continue in that rotational path. Okay?
Mr. Sensible. At what point does that happen? Because, we're at 2 Tor, which is low vacuum.
No, it's medium vacuum. You've misread the scale because you don't understand the exponent scale.
It's not strong vacuum, it's not high vacuum, but it's low vacuum. So at what point does that happen? We know that airplanes fly in the lower stratosphere, and they like to fly in the lower stratosphere. So there is gas pressure there, plenty gas pressure there.
Atmospheric pressure. But yet there's pressure even out in the depths of space. Not a lot, but there is some.
It's not high like we have it at ground level, but it's there. But at 37 kilometers up, I don't know. It doesn't seem correct that you could claim the conservation of momentum that we are being brought along with the atmosphere that's being brought along by the globe out.
Well, unfortunately, Brian, it doesn't seem correct. It's not evidence. You'll need to do something to show that that's wrong.
As you're also claiming a vacuum.
I'm not claiming a vacuum. I measured a vacuum. But then ground level is low vacuum. And if anyone's going to say, aha, your temperature sensor was out, so your pressure sensor was as well, they need to, again, watch the experiment video where you can see the size of the balloon change from its initial size of around 1.5 meters across to about 8.5 to 9 meters across when it finally burst. No gas was added. The reason it expanded was the surrounding pressure, atmospheric pressure, was reducing and reducing. So therefore I don't even rely on the pressure sensor, which was sanity checked against the top of Everest height, and also produced the gradient graph, which matches known science. But forget that. You could see it just with a balloon.
You know, you did claim there's a vacuum. So I don't know what that's about. But
yeah, it's a vacuum. You get varying levels of vacuum.
There's no rotation. There's no rotation to be seen in the video.
No, of course not. Because that's not what happens. It's not what's expected to happen either. The only people who claim we should see that are flat earthers who do not understand that there is conservation of momentum. I'm sorry, but that's not my problem.
And the temperatures are way higher than what we, like, according to...
Look, you don't need to go back to the temperatures. I've acknowledged that. That reading is higher, and perhaps all the readings all the way up were higher than expected, but they still followed the same gradient. I have conceded that the reading for the temperature is out. But as I also said, that does not affect the shape of the Earth, which MAGE has demonstrated.
According to this here, at 27 kilometers up, we should only have minus 20. And it's, let's say minus 10, right? Minus 8, minus 10. And Mr. Sensible's MAGE has a plus 4.8 Celsius. So something very wrong there. So temperature's too high, no rotation. And then there's this issue.
Right, finally we get to the third issue. So we've had the temperature, which isn't an issue, but is a data misreading. We've got the Earth not apparently turning underneath, which we don't claim anyway. And so now we move on to this, the third issue. Come on, knock it out of the ballpark then, Brian.
Issue. Where is the curvature?
Right, snapshot. We'll have a look at that picture in a minute. Tell us about it though.
There is a line here with arrows. This is, I just took it at 2 hours 19 minutes. You can see it down here, 41 seconds. But I tried to get it as neutral as possible, and I put a line there. There's no curve. And I did another one a few seconds later. I got another still. There's a thin red line there. No curve.
I've snapshotted that one as well. We'll have a look at both of those, Brian. However, I do notice that once again the horizon images you have chosen happen to be right near the bottom of the image, where any barrel distortion will be at its maximum and would tend to flatten any curve, instead of between the two reference string lines, which are there to act as a reference, and it's the central area where there is no distortion. So whatever the shape of the Earth is, globe, flat or dodecahedron, that's where you see the best chance of spotting it. But of course, for some random reason, every flat earther likes to pick images of the horizon in the bottom third. But let's see how I get on looking at those, shall we, in a minute?
So there's no curvature. No curvature to be seen. The temperatures are too high, and there's no rotation. So I'm sorry, Mr. Sensible, but this is not a globe proof.
Okay, Brian, here's the two snapshots. We'll start with the second one. So if we take that image and we will rotate it just to get your red line as level as I can, about there. That looks pretty good to me. Now what we'll do is we will compress it left to right and see what we get with each image. So there's the first one. Let's save that. Right, let's move on to your first image. Again, we will rotate it to get your purpley line sort of as horizontal as I can by eye. Out there. Then we will again compress it to the same amount. Save that and see what we get. So Brian, this is your second cherry-picked image from the bottom of the screen, where barrel distortion will tend to flatten any curve. It appears that once we've compressed it, you can see there's a slight curve, but only very slight. Let's have a look at your other image. Remember, this was your image that you chose from the bottom third of the screen, where barrel distortion favours yourself. All I've done is rotated it slightly to get it horizontal, compressed it side to side, and what can we see?
So there's no curvature. So there's no curvature.
So there's no curvature. So there's no curvature.
I don't see how the fact that the temperature's reading, say 10 degrees or 15 degrees more than it should, proves the Earth is flat. I fail to see how the fact you can't see the Earth turning under the balloon, when we don't claim that you should see the Earth turning under the balloon, is proof of a flat Earth. And your two cherry-picked images, which apparently show no curve, both show curve.
So there's no curvature. So there's no curvature.
So there's no curvature. So there's no curvature.
So no, I wouldn't take that as proof for a flat Earth.
That has a pressure gradient because of gas cycles,
What?
convection,
What?
density gradients.
What? Gas cycles? Convection currents? You already had shown in one of those articles that in the stratosphere there's virtually no convection. And how would convection work if you've got a temperature that's getting lower and then higher? How's that going to work then? Brian, I'm sorry, you're making wild ass assertions there, and you're pulling them out of your wild ass.
I don't see how it's any kind of a proof of a globe. You have to have curvature, you have to have rotation.
Yes, you've got curvature. Yes, the Earth rotates, but not between the balloon and the Earth. The whole thing is rotating. That's why the stars move across the sky. That's why the sun apparently moves across the sky. There's your visible rotation.
You have to be matching what they say, right, from weather.gov.
Well, it'd be nice if my temperatures did match, but that's superfluous with regard to the shape of the Earth. Are you saying that if that was 4 degrees lower, the Earth would be a globe?
I mean, they say, there we are, weather.gov, this is what they say, stratosphere.
We know what they say, Brian.
37 kilometers up, they're saying, in this one it's minus 15, another one they said 0.
Yep, you told us that about 10 times.
So, it's at most 0. It can get to 0, that's what they said.
Yes.
You have plus 4.8.
Yes.
So, temperature is way more than what the official line says. No curvature.
So there's no curvature.
Yes, there's curvature. I showed you on your own cherry-picked images.
The official line says there should be, and no rotation, like the official line says there should be. So I'm sorry, but this is proof of a flat Earth.
Well, if you think that I've proved the flat Earth, I suggest you write a paper and submit it to a journal. Maybe you could go for the Nobel Prize, because I don't think that's proof of a flat Earth. I think it's just the opposite.
So there's no curvature. So there's no curvature.
So there's no curvature. So there's no curvature. So there's no curvature.
Oh dear, I think I've gone and broken my flurf. I think next we need to look at the MAGE rage list. Well, a mixed bag really there, Brian. I want to give you credit for spotting and raising a query over the temperature readings and then researching what they should be. So that gets you onto the worthy attempts list. But as for the Earth rotating under the balloon, and as for saying there is no curve in 2 cherry-picked images that show curve, you also go onto the MAGE rage list. The first person to go on both. Thanks for the attempts. I hope you all enjoyed that. Look forward to seeing you again soon. Until next time, stay sensible.
Shut up and sit down.